All right, let's get right into it. We're taking a trip out to the asteroid belt to check out a world that scientists for decades thought was the literal metal heart of a planet that died a long, long time ago. The idea was its rocky layers were violently ripped away in the chaotic early days of our solar system. But, as we're about to see, the real story of asteroid 16 Psyche, it might be even weirder than that. And there she is. Look, this is not just another space rock. Psyche is huge. We're talking about 222 kilometers across, and its surface seems to be just loaded with iron and nickel. It's so packed with metal that for the longest time, it was seen as this totally unique object, Our one and only shot to visit a planetary core without having to drill through thousands of kilometers of rock. So the old story went something like this. Way back when the solar system was young, giant planets like Jupiter were moving all over the place, and their gravity was just throwing everything into complete chaos. The theory was that a young planet, maybe the size of Mars, got hit so unbelievably hard that its rocky outer layers were just gone, blown away into space, and all that was left behind was its dense metallic core. That core became the asteroid Psyche, a super dramatic, violent origin story, right? But what if that simple, brutal story is wrong? See, as scientists started gathering more and more data, a few key details just weren't lining up. It forced them to question pretty much everything they thought they knew about this bizarre world. And that's where the real mystery begins. So, how in the world do you solve a mystery from hundreds of millions of kilometers away? Well, you basically become a cosmic detective. You start piecing together clues from all sorts of things: radio waves, heat, even visible light. And each one reveals another little piece of the puzzle. To really build a complete picture of Psyche, researchers had to combine data from 3 of the most powerful kinds of telescopes we have here on Earth. Each one gives you a totally unique perspective, a different layer of information that when you stack them all together, starts to bring this distant world into sharp focus. Okay, first step, radar. By bouncing these incredibly powerful radio waves off Psyche, using the legendary Arecibo telescope, astronomers could actually peek just beneath its dusty surface. This technique basically works like a cosmic metal detector. It can tell you how much metal is in the top meter or so of its regolith. That's just the loose layer of dust and broken rock covering the surface. Next, they pointed the ALMA telescope array in Chile at it. Now, instead of looking at reflected light, ALMA sees heat. By mapping how Psyche radiates its own heat out into space, scientists could get these absolutely crucial details about its overall shape, its size, and even get a feel for the texture of its surface. And finally, for the most direct look, we go to the Very Large Telescope, which uses this amazing technology called adaptive optics. What that does is it cancels out all the blur from looking through Earth's atmosphere, and it gives us these incredibly sharp, actual visual images. This is how they map the real geography, the craters, the big depressions, and all the other features on Psyche's surface. So what happens when you take all that data and put it all together? Well, all those clues, the radar, the thermal scans, the optical images, they combine to let us move way beyond just some blurry dot in the sky and create a detailed 3-dimensional portrait of this alien world. By feeding all those different clues into some seriously powerful computer models, scientists were able to create the most accurate, highest resolution shape model of Psyche that's ever been produced. It's really the result of years and years of observation, turning all these scattered data points into a tangible object we can actually explore. And this model gives us some really precise dimensions. Psyche is definitely not a perfect sphere. It's more like a lumpy potato measuring 278 kilometers at its longest point. Just to put that into perspective for you, if you could just plop it down here on Earth, it would stretch from Washington, D.C. almost all the way to New York City. We're talking about a seriously big object. Now here's where it gets really cool. We can see it's not just a lump of metal. This is a world with its own geography. Scientists have already identified and started naming its biggest features, like these huge flat-looking regions they've called Alpha and Bravo, and this massive crater-like depression down in the southern hemisphere. It's a world with a complex landscape. So this detailed portrait was a huge leap forward, but it also revealed a fundamental, gigantic flaw in that original story. Just one number, one single measurement, threatened to unravel the entire exposed core theory. It all came down to a pretty simple question of physics, really. If Psyche was truly just a solid chunk of iron and nickel, then it should have a very specific and very, very high density. I mean, pure iron has a density of about 7,900 kilograms per cubic meter. For that whole stripped core idea to hold up, Psyche's density had to be somewhere in that ballpark. This wasn't just a guess, it was a non-negotiable prediction of the model. But then, when scientists used their new, super-accurate shape model to calculate Psyche's actual bulk density, the number they got back was just shocking. It was around 4,000 kilograms per cubic meter. That is barely half of what it should be. The math it didn't work. At all. And this was the case-breaking question. Where did half the density go? You can't just lose 50% of an asteroid's density. This problem was so huge, it sent scientists right back to the drawing board. The metal heart of a dead planet just couldn't be the whole story. Something else had to be going on. So, with the main theory in serious doubt, a new suspect had to be found, and all the evidence was pointing away from a simple, solid core and toward a much more complex and honestly a way more exciting possibility. Okay, so right now there are three main theories on the table. The original stripped core model, it's pretty much out, mainly because of that huge density problem. Then there's the rubble pile idea, which suggests Psyche got shattered and then just loosely clumped back together. But that theory kind of struggles to explain how such a big object could reform so loosely. Which leaves us with the new frontrunner, that Psyche is a differentiated world, one that formed with both a metal core and a rocky mantle, and that most of that mantle is actually still there. And this new theory comes with a totally mind-bending idea: ferrovolcanism. It's a wild word for something even wilder: volcanoes that erupt molten metal. The idea is that molten iron from Psyche's core, made more runny by things like sulfur, could have forced its way up through a thin, rocky mantle and literally erupted onto the surface. Iron volcanoes. And what's great is this new model elegantly solves the whole puzzle. A world made of both rock and metal would naturally have a lower overall density, which matches what we see perfectly. Metal volcanoes? That would explain why its surface is so rich in iron and nickel. And it would also explain why those radar scans see these specific patches of really high metal concentration. Those could be the ancient lava flows of molten iron. It just fits all the clues. But look, as convincing as this new theory is, these are still just models. They're based on data we've collected from way back here on Earth. To really, truly know the answer, well, we have to go there. And that is exactly what is happening. All this incredible groundwork, creating these detailed maps and these complex models, is basically the treasure map for NASA's Psyche mission. The spacecraft is literally on its way there right now, packed with instruments designed specifically to test these theories and finally solve this mystery once and for all when it arrives. So that's the ultimate question that's waiting for us. When that spacecraft finally settles into orbit around Psyche, is it going to confirm that old dramatic story of a planetary core laid bare by a cosmic smash-up? Or is it going to reveal something far stranger, far more exotic? A unique world of rock and iron, a world shaped by volcanoes that once spewed molten metal across its surface. We are so close to finding out.